Let's remember back to what our overall goal is. We saw these two lava flows, one flowing near one village, one flowing near another village, and they were moving at totally different speeds, and we wondered, why was that? So we have to figure out how we discovered an answer to our question yet. We wanted to know what caused these differences. And then we started refining our question to the point where we said, does the lava's temperature affect the speed at which it flows? And so I think we might have an answer to that. And so here we have, does the lava's temperature affect the speed at which it flows? And here's Ida's answer. Yes, I found that the cold lava flowed faster in my experiment. And of course, that's different than what you found. So you say, wait, I found the opposite for my experiment. Hot lava flowed faster. So we have these two students that are trying to come up with what do we do? Because they both experience different things. Their data shows something different. They're being good scientists. They're using their data. But what we need to do is we need to realize that one data point is not enough. And so what did we do? We looked at the patterns here. We looked at all sorts of different data points from many different people, and we saw that the hot lava was consistently flowing faster. And so we said, what's the pattern that you notice? I noticed the pattern that the lava that is hotter flows faster. And then we said, let's take a look at what this would look like on a graph. And we said maybe it would look like this, or like this, or like this, or like that. And then we actually went and we looked at our data, and we saw that the average was going across here. That as you get from warmer and warmer, the lava takes shorter and shorter amounts of time. It goes faster and faster as it gets warmer and warmer. And we see this consistent trend, a special type of pattern that goes in one direction. So the class comes up with this claim: the hotter the lava, the faster it flows. But Ida says, I don't agree with that claim because I found that the cold lava was faster. I found the opposite. So we need to help Ida really appreciate and understand what's going on here. Did she do something wrong? Possibly, but more likely there's something else going on. So what we have is we have to think about this from the perspective of cause and effect. And so we're suggesting that there's something to do with temperature and something to do with the ability to flow or gooiness. And so which of these is the cause and which of these is the effect? Good. So we think that the temperature should be causing or changing the ability to flow of a liquid. But is that the only cause? Maybe there are other factors, and those other factors might be what happened with Ida's activity. So we say causes. And so can you then explain Ida's results using this diagram? That she actually was falling prey to having some of these other factors becoming more important. And this happens all the time where people did something just a little bit differently, and it turns out that that little difference is some other factor that ends up causing a really big difference in their final result. So we go back here and we check, have we actually answered our question? And I think we have, except that let's just go ahead and test out to see if it works, if we go back to our original phenomenon and try to explain it, the what caused, why, or how. So if we're looking at our two lava flows, here's the slow moving one, 10 to 15 yards per hour, and then the fast one, more than 17 miles an hour. And so which of these would you think is the hotter lava? Okay, well, let's go ahead and compare that here. These are these directions that we are looking at here. On the left side is the southeast cone overflow, and that was here. And on the right side is the near Leilani village, is this Kahu'alea lava tube. And if we're looking at them, which one looks like it's hotter? Well, it seems like the southeast cone is hotter, so that means that it should go faster according to our claim, but it doesn't quite look that way. So we have a little bit of a mystery. Maybe we need to understand a little bit more about this southeast cone overflow and what a lava tube is and what the difference is between those two things, because that's going to be the key here. If you're taking a look at these in regular light, in the light that we see with our regular eyes, which one here looks hotter? Well, now all of a sudden, maybe the right side looks hotter. And is it hotter uniformly? Well, not necessarily. There are certain spots that seem a little bit more bright where the steam is escaping, and you can kind of maybe see those in here. So let's try and get a better sense of what overflow means versus lava tube. Cone overflow is a lot like what it sounds like. There's a volcanic cone, that's the little mountain, the vent where the lava is coming out, and it gets so much coming out that it overflows into a river of lava that moves across the surface. If you're flying over a lava tube, it looks very different. Sure, there's a lot of dried up lava here, but where's the fresh lava? Ah, there it is. You can start seeing a tiny bit of it through what's called a skylight, which is a little opening, and below there you can see this lava flowing down through a tube that's mostly covered up in this picture.
And today is lava tubes, volcanic lava tubes. All right, gang, let's go.
Thank goodness this man is walking in an ancient lava tube, because where he's going right now would have been filled up with all that hot, molten liquid lava when it was active. But now the lava's drained out and leaves behind a tube like this. And even you can see a skylight. Now that we have a better understanding of that, what I want you to do is I want you to create a scientific explanation for why is this lava flowing slowly and this lava is flowing fast, and tie together all the observations that we have in here. The observations of temperature, the observations of the way that the lava is moving across the ground or under the ground, and go from there. I'm looking forward to seeing your explanations.